Dear students, as we have already discussed virtually on fifth experiment on the topic comparison of EMF of two cells using potentiometer. Now, here I am going to discuss the next experiment on the topic to determine internal resistance of a cell using potentiometer. So in the last class, because of weak network, the same class was not properly uh, conducted and not all students even attend the class. So again, I repeat the same class. So just be active to understand first theory part of the experiment. Main objective of this experiment is to measure internal resistance of a given primary cell using potentiometer. And theory of this experiment is as a potentiometer is a device, has already been discussed. It is a device used to measure the internal resistance of a cell or to compare the EMF of two cells and also potential difference across resistors. So this device meet the three purpose. First one is to compare EMF of the cell, two cells that has already been discussed in the fifth experiment. And the second one is, which is most important in context with the board examination, that is to measure internal resistance of a primary cell. And potentiometer consists of long wire of uniform cross-sectional area and of 10 meter in length. As I have told you that it is not limited up to 10 meter only. Its length may be even larger than that of 10 meters. If it is larger, then accuracy will be much more. You know well that potential difference across the length of the wire is directly proportional to length. That's why if you increase the length, then sensitivity of potentiometer per unit length will be more sensitive. The material of wire should have high resistivity and low temperature coefficient. That has already been discussed in the previous experiment. And the wires are stretched parallel to each other on the wooden board. The wires are joined in series by using thick copper strip, and also a meter scale is provided or attached on the wooden board to measure the balancing length. Now, working principle of potentiometer has already been discussed in the previous experiment. So here once again I explain it, because while you are being asked to measure the internal resistance, you must explain the theory and working again. So potentiometer works on the principle that when a constant current flows through a wire of uniform cross-sectional area, potential difference between its 2 points is directly proportional to the length of wire between the 2 points. Mathematical part of this experiment is that we must follow the relations and previous knowledge that you would have studied in Ohm's law. That is, potential difference across the ends of conductor is proportional to current, and hence potential difference is just equal to product of current and resistance of the conductors. So here, if we connect a cell in a circuit in series with the external resistance R, capital R, then effective resistance of the circuit will be sum of external resistance and internal resistance of the cell. That is, internal resistance is represented by small r. So if a cell of EMF E and internal resistance R connected to an external resistance R, then circuit has the effective resistance capital R plus small r. Because these are connected in series, therefore effective resistance is just equal to sum of external resistance and internal resistance of a cell. So in that case, using Ohm's law, potential difference is just equal to product of current and net effective resistance of the circuit. So as current is constant in the circuit, so I into R plus R, that is, so EMF equal to I into capital R plus small r. You know well that a small r is internal resistance of the cell and capital R is the external resistance that can be measured easily and that can be inserted into the circuit using resistance box. Now, so if you break the bracket, then there will be I into R plus I into R plus I into a small r. So you know well that I into R is just equal to potential difference according to Ohm's law. So I into R equal to V, or I into R equal to E minus IR, you know, in here. So now from here, we can determine R, a small r is to be determined. So this means V is less than EMF of the cells. Here we understand that R can never be zero and I can never be zero because I has to be constant. Then V equal to E minus IR. So potential difference becomes a little bit less than that of the EMF of the cell because of presence of internal resistance. So, and equal to the fall of potential inside the cell due to the internal resistance, because of internal resistance arise because of the materials or chemicals used in forming the cell or designing the cell. From the above equation here, we understand that in place of I, we can place V over R. In place of I, we can place V over R here in this case. Then V over R, V equal to E minus V over R into a small r. You understand well. Therefore, R over capital R equal to E minus V over V, and hence small r equal to E minus V divided by V into capital R. So this is the theoretically expression for the internal resistance of a cell. And using potentiometer, this is theoretical part. Using potentiometer, we can adjust the rheostat to obtain the balancing length L1 and L2 of the potentiometer for open and closed circuit respectively. Try to understand. L1 is for open circuit and L2 is for closed circuit. Once you measure the balancing length for open circuit, and again once you measure the balancing length for closed circuit, and name this length as L1 and L2. You know well here. Now try to understand. This is the circuit diagram. So we understand here, here is the circuit diagram. This is the cell. This is the potentiometer. And one terminal of potentiometer, say P, is connected with the positive terminal of the battery or eliminator. And other terminal of potentiometer is connected with the negative terminal of the battery along with the ammeter and rheostat. And so here another terminal is Q. Now, positive terminal of potentiometer is connected with the positive terminal of the cell whose internal resistance is to be measured. And this is the shunt resistance, or you can say external resistance. And here is the high resistance box. Okay. And one terminal of high resistance box is connected with negative terminal of the cell as well as one of terminal of the shunt resistance. and other terminal of high resistance box is connected with the galvanometer, and another terminal of galvanometer is connected with the jockey key. That's the okay. Now, once we once we measure the balancing length of the circuit when circuit is open, and then we measure the balancing length when circuit is closed, and hence we get, when circuit is open, then we get the EMF of the cell in case of open circuit. So open circuit, E equal to KL1. And when circuit is closed, now EMF is no longer there, but there will be potential difference, which is a little bit lesser than that of the EMF, and it is given as V equal to KL2. So where K is proportionality constant, or called potential gradient along the length of the wire. Now we can now modify the equation for getting the internal resistance of given cell by using the above relation from here, replacing E by KL1 and V by KL2 in this expression here. So we get the result this, because E and V is not to be measured here. Now length L1 and L2 can be measured using the scale provided on the wooden board of the potentiometer, and R is already known from the resistance box or from the shunt resistance. So measuring length L1 and L2, one can measure internal resistance of the cell. So this is the theoretical part of the, and learning outcome of this circuit, this experiment is that a student get the idea of potentiometer apparatus and its parts. One, second, students are able to construct circuit based on circuit diagram like this. You have to learn using by looking the circuit diagram, you can complete the circuit in a real physics lab. Now, a student understand the different components used in the experiment. This is the learning outcome. Now, we have to move ahead on the next part of this experiment is procedure. Before starting the experiment, we have to follow the following procedure, that is material required for the experiment. So first thing is that potentiometer is required, and second one is battery or battery eliminator, and we need two one-way key. Remember, two one-way key and a rheostat of low resistance. Keep in mind that rheostats must be there, but of low resistance. Almost you can say of 10 ohm range, 0 to 10 ohm, and a galvanometer and two resistance box. Here, in order to perform this experiment, we need two resistance box and a Lackland cell whose internal resistance is to be determined, because this eliminator will provide energy to the potentiometer for its working, and this Lackland cell will be connected here in this circuit. Here Lackland cell will be connected and eliminator will be connected here. Okay, so this eliminator will supply energy to potentiometer for its working, and this Lackland cell will be used here for measuring its internal resistance. And two resistance box is there. One resistance box will be here in order to provide shunt resistance, and other high resistance box will be here. Now try to understand. So these are the procedures, and a jockey key is must be there, and ammeter. An ammeter must be there for measuring current. Constant current has to be supplied across the circuit during performing the experiment, and last one is the connecting wires required. In real lab, procedure follow like this. This is the potentiometer. This point P stands for the one terminal of potentiometer, and point Q stands for the another terminal of potentiometer. In your lab manuals, it may be A and this may be B. So try to understand. P stands for positive and Q stands for negative terminal of potentiometer. Or even you can say P stands for negative and Q stands for positive as here in the diagram, Q for positive and P for negative. So a potentiometer can be connected in any order. There is no important of order has to be followed, because potentiometer's terminal uh, is not followed positive and negative. So once you decide, it depends upon you whether which terminal you make positive and which terminal you make negative. Okay, try to understand here. This is the circuit diagram. So potentiometer, first of all, connected. One terminal of potentiometer is connected with the positive terminal of battery or eliminator. This is driving battery or eliminator that supply the energy to the potentiometer for its working. And negative terminal of eliminator or battery is connected with one of the terminal of key 1, and other terminal of key 1 is connected with the negative terminal of ammeter, and and positive terminal of ammeter, just you can reverse it. Positive terminal of ammeter is connected here, and negative terminal of ammeter is connected here with one of the terminal of rheostates, and another terminal of rheostat is connected with the one of the terminal of potentiometer. Now that's okay. This was the connection of potentiometer. Now Lackland cell, whose internal resistance has to be measured, is to be connected. How? Here, try to understand. One terminal of the cell whose resistance, internal resistance, is to be measured is connected with the point Q of the potentiometer, or positive terminal of the potentiometer, and the positive terminal of the battery or Lackland cell is connected with a rheostat of low resistance, and another terminal of rheostat is connected with the key K2, and then another terminal of K2 is connected with the negative terminal of the Lackland cell, and same Lackland cell uh, is connected with the negative terminal of Lackland cell is connected with the galvanometer, one of the terminal of galvanometer, and other terminal of galvanometer is connected with the high resistance box, and other terminal of this box is connected with the jockey key. Now we check if jockey key is placed at this point P and at this point P, and if you see the galvanometer deflect in opposite direction, then you must understand that connection is accurate and right. Arrange the required material on the table and make the connection as per the connection diagram. This is the circuit diagram. Then, and make sure that tight the plug of the resistance box, and to test the connection, insert the key 1. First of all, to test the connection is right or wrong, just place key 1, insert the key 1, and note the ammeter reading. If ammeter gives reading, then you must understand that connection is right. Now introduce a specifically high resistance on the resistance box from here. Okay, and then place the jockey key at the two end. Sufficiently high resistance after providing, then place jockey key. And if galvanometer shows opposite deflection at the two end of the potentiometer, then connection are right and correct. Now, without inserting key 2, that is key 2, slide the jockey key along the potentiometer wire and stops when null point is obtained, and note down the length of wire or balancing length of wire, and say this balancing length is L1 between this point and one of the end of the point P of the potentiometer. And now introduce a plug key K1 and K2. In next part, we press the two key simultaneously and then take out the small resistance from the resistance box connected in parallel, which act as a shunt resistance, and then follow the same procedure. Again, slide the jockey key along the potentiometer wire to obtain the null point and measure the new balancing length L2 based on these points. Now, after doing this, reduce the value of resistance R successively, and in each time measure the balancing length. Now R will be, R is what? Here shunt resistance. We reduce the shunt resistance at least 4 or 5 times, and each times we measure the length, And if you measure 5 times the length, then take the mean value of that length, and that length will stand for L. Okay, and keep the reading on ammeter constant throughout the observation. This is the most important point. There must not be variation of current in the ammeter. If current varies during experiment, then there will be error. As you have already in theory part learned that current must remain constant. Then potential difference across the length of conductor will be proportional to length of the conductor. So now we move on the simulation part that we have to show you in a virtual lab. And in that simulation part, this is the procedure. Select the primary cell first from the drop down list and select the rheostat resistance using the sliders. And to see the circuit diagram, click on the show circuit diagram that I will show you. These are the and make observation table like this. This is R. This table stands for R, shunt resistance. And this is the position of null point for L1 and L2, length L1 and L2. And then we, this is first column, which stands for serial number. This is second column, which stands for shunt resistance. And this is the third column, which has two parts for length L1 and for length L2. Length L1 stands for without shunt resistance R, and L2 stands for shunt resistance with shunt resistance L2. And fourth column is, stands for expression for internal resistance that I have already derived in theoretical part. So placing value of L1 and L2 from this column and from R from this column, we can measure the value of internal resistance R in this column, and in this way we will get 5 readings or 5 value of internal resistance. After completing the experiment, the 5 value of internal resistance, we can measure the mean value of internal resistance, and that mean value of internal resistance will be true value of internal resistance of the shell. Now calculation part. Calculate the value of R for each set of L1 and L2, and the mean value of calculated value gives the internal resistance or true value of internal resistance of a given cell. Now result has to be placed here, the internal resistance of given primary shell. Whatever mean value you get must place here. Okay. Now first of all, we move on animation part of the same experiment. You just look.
Potentiometer, internal resistance of a cell, circuit diagram, materials required, ammeter, one-way key, rheostat, battery, potentiometer, resistance box, Lagrange cell, one-way key, high resistance box, and galvanometer. Procedure. Connections are made as seen in the circuit diagram using the connecting wires. Insert the one-way key K1. Adjust the rheostat and note the ammeter reading. To check whether the connections are correct or not, place the jockey at the two end points of the wire. If the galvanometer shows opposite deflections, the connections are correct. Without inserting the key K2, Slide the jockey over the potentiometer wire and stop when the galvanometer shows zero deflection. Measure the length from point P. It is taken as the balancing length L1. Record the value in a tabular column. Now introduce a low resistance of 0.2 ohm on the resistance box. Insert the one-way key K2. Again, slide the jockey over the potentiometer wire and measure the balancing length L2. Record the value in a tabular column and calculate the value of internal resistance R. Introduce a low resistance of 0.5 ohm. The key K2 is inserted into the switch. Slide the jockey over the potentiometer wire and measure the balancing length L2.
जी गए हैं लेके गए हैं आज आपको किसी समय मिल जाए
Record the value in a tabular column and calculate the value of internal resistance.
जी जी नहीं आज मिल जाएगा सर आज लेके चले गए हैं हमारे जी
Introduce a low resistance of 1 ohm. Slide the jockey over the potentiometer wire and measure the balancing length L2. Record the value in a tabular column and calculate the value of internal resistance. Repeat the experiment by reducing the value of R low resistance successively and each time measure the balancing length and calculate the mean value of internal resistance. From the experiment, it is found that the internal resistance of a cell increases with external resistance and the average value of internal resistance of the given primary cell is 2.502 ohm.
Okay, so we have learned about this experiment. Now we have to move on the simulator part. Okay, that has to be learned from here. This was the animation part that we have learned that experiment. Now here we will work in a real lab. So virtually here we will act as a working in real lab. So we move on simulator part. Okay. You see here, you see this is the potentiometer. First of all, we have to make a connection. We should select first of all Lackland cell. Yeah, Lackland cell, as we have explained. We have selected Lackland cell. Now, first of all, look at the circuit diagram. You see here, part P, that is point P of ammeter, is connected with the positive terminal of the battery or eliminator, and negative terminal of the battery or eliminator is connected with key K1, and other terminal of key K1 is connected with the negative terminal of ammeter, and positive terminal of ammeter is connected with the rheostat, and other terminal of rheostat is connected with the point Q of potentiometer. First of all, we have to connect this one. Then we will move on this connection. Okay. So first of all, move on. Say if this is point P1, then take this is the eliminator or battery that will supply energy to the potentiometer for its working. This battery is not that one whose internal resistance is to be measured. So this is supplier, and battery as Lackland cell is this one. So its internal resistance is to be measured. So first of all, connect this with the positive terminal of potentiometer. It's okay. Now, negative terminal of this battery must be connected with one of the terminal of 1 by key 1. You understand here in the circuit. Negative terminal of battery must be connected with key1. So, and other terminal of key1 must be connected with the negative terminal of potentiometer ammeter. So uh, here we connect this one as. Okay, that's nice. Now, positive terminal of ammeter is to be connected with the one of the terminal of rheostat. That is, this is positive terminal. So must connect with this part. You know well that if you connect at this part and this part, then it will act as a fixed resistor. So we must connect one terminal here, another terminal here. Now, other terminal of rheostat, as you have learned in the circuit here, other terminal of rheostat must be connected with the point Q of the potentiometer. So here, other terminal of rheostat is connected with the point. Okay, right? Connection is done. Now, this is well done. Now, next part is here. You see here one terminal of the positive terminal of the Lackland cell whose internal resistance is to be measured must be connected with the point P, and the same positive terminal must be connected with one of the shunt resistance box. So first of all, do like that, and negative terminal of this cell is connected to K key 2 as well as high resistance box. So move on. Let us check one of the positive terminal of the cell. If black one, okay, let me, now time is not so much, 10 minutes. Within that one, we have to work. Positive terminal, it must, if black one is negative, so black must be connected with the, okay, K1, okay, see. Positive is to be connected, let me check. It will take automatically, right? Positive one has already been connected, and one of the positive terminal also connected with the one of the terminal of resistance box, correct? And other terminal of this resistance box is connected with this K key 2, and negative terminal of this cell is connected with this. Okay. No, it will not take. So I think that I will take, you see here. Negative terminal of the cell must be connected with the high resistance box here. So we must connect this negative terminal with the high resistance box. And let us check what is time. Okay, I will perform this experiment within that time. And now negative terminal of the cell is connected with the one of the terminal of this resistance box. So check. No, it is not taking. Yes, now it's correct. Now, one of the terminal of this cell has to be connected with this resistance box. Okay, yeah, here. Okay, now correct. Now again, see the circuit. So another terminal of this high resistance box is connected with one of the terminal of the galvanometer. And so move on. So one of the terminal of high resistance is connected with this one, red one. And next one is connected with the jockey key. Correct? Connection is over. All right. So first of all, we have to check out without inserting this key, just press this key and then check reading. Yes, connection is right. Here ammeter gives reading. So and now you take out the balancing length without inserting this circuit. So rheostat's resistance can be varied using this. And here you see current is changing, getting decreased. Okay. But remember, you have to keep the current constant. So if you keep a resistance in the circuit as a 4 ohm here, rheostates has fixed. Why we have fixed the rheostat? Because to keep the current in the ammeter constant. So right now current is constant in the rheostats. Even we can decrease. Now this is 9.1 and okay, now just keep it 50 by giving 2 ohm resistance. So current will remain constant fixed in the circuit. Now we have to check jockey key. If you take the jockey key at this end, galvanometer gives you 0 reading here, 0 reading, and move, gives the positive 30, 30, okay, which find somewhere must be there, 0 reading. Okay, yeah. It means somewhere galvanometer show negative reading. So somewhere must be 0 balancing length. Gently. Okay. So this is the 0 balancing length. We will note down. This will be L1. This will be L1 without inserting shunt resistance. This is L1. Okay. You will note down. Now, uh, now you have to uh, insert K set shunt resistance, and then we take out one of the resistance. Say here we take 0.1 resistance from the shunt resistance we insert. Okay, now in the circuit shunt resistance has been inserted, and now press this key K2. Okay, and again you slide and search out the balancing length, balancing length. Okay, so in this case, balancing length. Okay, in this case, balancing length is 31 cm. Okay, this will be L2. Similarly, now again take out this key K2 and now insert another value of shunt resistance, and again press this K key to. Okay, Now again, you have to find out the balancing length and so on. Again, you have to measure L1 and L2 each time. So here, remember, by inserting a resistance and just take out this K2 and insert resistance of 0.1 ohm and then vary the balancing length. Okay, as we find negative here, negative here. Okay, so 790 cm is the balancing length L1. You just note down. And now, next thing is that for the inserting shunt resistance 0.2 ohm, yeah, here we, and then we measure the balancing length L1. Balancing length L1. Okay, even at 0.2, this is balancing length is this much. Now, what we have to do, we have to press the K2, and then we have to insert the resistance uh, 0.5, say here 0.5 ohm we insert, and then uh, measure the length L1, measure the length L1 for 0 reading. Okay, here we get 789.5 L1. Now for the same shunt resistance 0.5, we measure L2. For L2, you must press the key. This one, K2 must be pressed, and then measure L2 for the same shunt resistance, and